All right, this lecture is going to be on momentum. This is going to be from pictures and diagrams and explanations that are from your online textbook. So here we go. We have to revisit Newton's third law, that action-reaction forces exist. And when we say this, we say that for every push, there's an equal and opposite. So you might be surprised to hear that rocket science is essentially the more gases that are pushed out is going to generate thrust in the opposite direction. So this is accelerating to the right because the gases are pushed out the back. So for every action force, there's an equal but opposite reaction force. The key points here, that when we look at action-reaction pairs, that both are always there when any force appears. They always have the exact same strength or magnitude, but they act in opposite directions. So we would say to the right is positive and left is negative. They act on different objects, and this is why they don't cancel out. Both forces are real, and either or both can cause an acceleration. Here we can look at an example of Newton's third law of action-reaction forces when we study the Earth and the Moon, that they are linked by an action-reaction pair. So when I look at this, the attraction force and reaction force, it doesn't really matter which is which. They both are acting on each other. That the Earth is pulling on the Moon and the Moon is pulling on the Earth. So when I look at, to try to define what momentum is, well, momentum is kind of this explanation of inertia in motion, right? Mass with a velocity. So momentum is mass times velocity, where we say P for momentum, M for mass, and V for velocity. That momentum, like inertia, measures an object's resistance to change in motion. That momentum also includes the effects of speed and direction, which is what we call velocity, as well as mass. So this truck traveling down this hill is speeding up. Therefore, it is gaining momentum as a result of increasing its velocity. So I can look at relationships of momentum, mass, and velocity, really looking at the relationships here. That momentum and mass have a direct relationship. That if I increase the mass, that the momentum will increase as well. Now we're assuming we keep velocity constant. Momentum and velocity have a direct relationship. This means that an increase in the momentum, the velocity increase is going to increase the momentum too. So if I increase V, I increase P. And that's assuming that mass is held constant. And mass and velocity have an inverse relationship. This means that as mass increases, the velocity decreases proportionally. Think of it this way. If I double the mass to keep the same momentum, I have to have 1/2 the velocity, and this is an inverse relationship. So if I solve these problems, right, some real basic application, momentum equals mass times velocity. So what is the momentum of an object traveling with 10 meters per second that has a mass of 10 kilograms? Well, 10 times 10 is 100 kilogram meters per second. That's my unit for momentum. Kilogram times meters per second. So which object has more momentum? A 40 kilogram object traveling at 1 meter per second, or a 10 kilogram object traveling at 4 meters per second, and why? Well, you'll find that 40 times 1 is 40 kilogram meters per second, and 10 kilograms times 4 meters per second is 40 kilogram meters per second. They have the same momentum. They both have a total momenta of 40 kilogram meters per second. It doesn't matter just because it's more massive. It's more massive and traveling proportionally slower, it's going to have the same momentum. And last but not least, a car has a mass of 250 kilograms. It's traveling 10 meters per second. Its momentum is 2,500 kilogram meters per second. So last slide. Momentum is a vector. Note that we use velocity in the momentum equation instead of speed. This is because direction matters. That we use positive values to represent up and right, and we use negative values to go left or down. So I want you to look at this picture. In the picture to the left, we see a skater tossing a medicine ball. The medicine ball is traveling to the right and has a positive momentum, right? Positive velocity. The skater has a negative momentum and negative velocity. It's traveling to the left. And we use arrows to explain this. So look at this. When they were together, they had no momentum. But after he tosses the medicine ball, it's traveling to the right. The total momentum to the right is 20 kilogram meters per second. The total momentum to the left is negative 20 kilogram meters per second. Equal in magnitude, opposite in direction.